Hi, Kylie. So today in this lesson, we will be dividing. So we covered the product rule, we covered the power rule, we covered combining like terms. And in this rule, we're going to be, excuse me, I'm yawning. Oh man, I'm tired. We're going to be dividing using the quotient rule. So the quotient rule says that if we're taking two exponential expressions like x to the power of a divided by x to the power of b, we do not actually divide the x's. We keep the bases of x the same. And what we do is we subtract the exponents. So this is like the opposite of the product rule. The product rule says if we have like x squared times x to the fourth power, we add the exponents together, that's x to the sixth. The quotient rule says if we have like x to the eighth divided by x to the third, let's say, we keep the x the same and just subtract. 8 minus 3 is 5. So that's the setup. That's how it works. So of course it's going to start out pretty simple, like x to the fifth over x to the third. And just so that you know, so you can kind of see it from a different angle, is that one too many x's? 1, 2, 3, 4, 5, no. X to the fifth power over x to the third. Technically, the reason this happens is because when you have a fraction, the same thing in the numerator will cancel out with the denominator if you have the same exact number. So that pair of x's, this pair of x's, and this pair of x's will cancel. And what we'll be left with is x squared. Using the quotient rule, we just take the x, subtract 5 minus 3, and again, we get x squared. K to the 12th divided by k to the second. 12 minus 2 is 10, so this would be k to the 10th. M to the third divided by m to the third. This one's kind of silly because when we have m to the third and m to the third, really everything cancels out. This actually just equals 1, but if we use the quotient rule, 3 minus 3 is 0, and I don't know why our notes don't go in this order, but anything to the 0 power just equals 1, so I would accept either answer here, m to the 0, or just 1 as the answer. We can make this a little bit more complicated by increasing the number of variables we have. In the next one, we've got a's and b's, but we just subtract the a exponents and then the b exponents. They have to have the same base in order for the quotient rule to work. So we'll do a separate one for the a's. 6 minus 2 is 4. And the b's, 4 minus 3 is 1, which we can just write a to the fourth times b. Or we can write it out as a to the fourth times b to the first if you wanted to include the 1 there. For the p's, 7 minus 4 is 3. 16 minus 12 is 4, so we would have p to the third, q to the fourth power. Now we've got x's, y's, and z's. This would be x to the 15th, y to the 0, or that just like cancels out, and then z to the first. So that would be an answer, or if you understand the y's cancel out, you could also have that as your answer. Now, the reason this can get a little bit more difficult is if we combine in some numbers to the mix. So if we add in like numbers in our fractions, like 6x to the fourth divided by 2x to the third, what's super important is we have to actually divide the coefficients like normally. If I gave you 6 divided by 2 like that, you would tell me the answer is 3. We still do that. So we cannot use the quotient rule for regular numbers. We just divide those normally and use the quotient rule for the variables. So 6 divided by 2 is 3, but x to the fourth divided by x to the third, that would be x to the first. So overall the answer would be 3x. 14 divided by 7 is 2. R squared divided by r to the first would be r to the first. S squared divided by s would be s to the first. So 2rs. All right, negative 36 divided by 4, that's negative 9. And then the c's are going to cancel because we have the same exact number. C to the 0 just equals 1. And d to the second power. For number 10, negative 15 divided by negative 3 is positive 5. X to the 6th over x to the 5th is x to the first. Y to the 5th over y to the third is y to the second. And then the z has nothing to use the quotient rule with, so it would just stay z. Now number 11 is interesting because when we divide 4 by 8, we get a fraction or a decimal. So 4/8 simplifies to be 1/2. And then it would be n to the fourth power. And then for the next one, even I'm grabbing my calculator. 36 divided by 54, math enter, that simplifies to be 2/3. And then this would be m to the 6th, n to the third. So that's the quotient rule. pretty simple when we're doing just that. But when we combine all the other rules into it, it does get a little bit confusing. So like number 13, we have to understand the order of operations for exponents. The first thing we always have to do is the power rule if we have a power rule problem. And then we can do either the product rule or the quotient rule in any order, but I usually do product rule first and then quotient rule second. But it doesn't actually matter. You could do these in any order or at like kind of the same time. And then if you have a plus or minus sign, then the last thing that you would do is combine like terms, which we don't see that yet. But for number 13, we would first use the power rule in the numerator. This would turn into 3 squared x to the 10th. Don't forget the power rule, you multiply exponents. Then I have 27x to the 3rd power in the denominator. Well, 3 squared is 9, and 9 27ths simplifies to be 1/3. All can be done in the calculator. And then this would be x to the 7th power. Okay, next one would be 2 to the 3rd power, a to the 6th, b to the 12th using the power rule, and then 4a to the 3rd, b to the 7th. 2 to the 3rd power is 8. 8 divided by 4 is 2. A to the 6th divided by a to the 3rd would be a to the 3rd because 6 minus 3 is 3. B to the 12th divided by b to the 7th would be b to the 5th power. So that would be our final answer. Okay, number 15, we have a power rule in the denominator. This is going to be 4 squared, which is 16, w to the 2nd, v to the 2nd. And 12/16, math enter, that's going to give me 3/4. And then y to the 7th over, v to the 2nd will be that answer. So that's how those work. I'm just going to skip some practice problems so that we can see some different types. Number 17, if we have an entire fraction being raised to a power, I think we saw these problems before. Basically, every single thing inside here is going to get the new power of 3. So this would become 2 to the 3rd, m to the 12th, n to the 6th, all over 4 to the 3rd, m to the 6th, n to the 3rd using the power rule. And then I'm going to use the quotient rule. Now, 2 to the 3rd divided by 4 to the 3rd. I'm literally just typing this in my calculator. I get a decimal, I hit math, enter, and that simplifies to be 1/8. Now for the m's, 12 minus 6 is 6, so m to the 6th. And for the n's, 6 minus 3 is 3, so n to the 3rd. Skipping around a little bit, we can see number 20 next. So number 20, we've got here, we've got parentheses up top, no power rule, but I would like to use the product rule first up top before I use the quotient rule, so I'm going to simplify that first. 9 times 4 is 36, and then for the x's, x to the 5th times x to the 1st is x to the 6th. Y to the 6th times y to the 1st, that's y to the 7th. And then I have over 6, x squared, y to the 4th. Now dividing this out using the quotient rule, 36 divided by 6 is 6. X to the 6th divided by x squared is x to the 4th. And then we have y to the 3rd there. So that's kind of everything that I feel like I really need to show you for the rules. Then the hardest questions would occur like number 25. Number 25, I see lots of stuff going on here. I see a minus sign holding together a first and a second separate thing. And what I want to do is simplify what looks like it needs to be simplified, which would be this first one here. So we have to simplify all of this, which I don't prefer to use the quotient rule first. I would prefer to like simplify this, making this negative 24, and then c to the 5th, d to the 3rd, all over 6c squared d before I do anything else. So that's my method. I like to do the product rule first before the quotient rule. Now I'm going to use the quotient rule, but first I'm going to divide negative 24 by 6 normally. And then for the c's, 5 minus 2 is 3. And for the d's, 3 minus 1 is 2. So we get negative 4c to the 3rd power d to the 2nd minus 9c to the third power d to the second. These are like terms because we have two different terms that both have c to the third and d to the second. So what I would do is just do -4 minus 9 more, and that's going to give me -13 c to the third d to the second. Now I'm going to be honest, questions that look like this, that have a minus sign or a plus sign, like number 26, like it's pretty, like I'm pretty certain that when I simplify this part, it's going to end up simplifying all the way down to r to the 7th, s to the 2nd, so that it can be added to that second one. So that's how that works. Usually these ones end up simplifying to be able to be combined with the other like term. So that is the quotient rule, and I feel like that lesson goes through all the different types of problems. And at this point, what I did was I had the students work on practice problems with the quotient rule. This is more like a review. The practice problems with the quotient rule would be this one here. So if you would like to use the rest of this time to complete this, numbers 1 through 20, we then can go over the answers. I hope you feel better. See you soon.